Following on from some of the earlier videos, we got to this stage here where the volume of this thing here, is given by this. So when you read this, it's saying sum up all the areas from negative infinity to positive infinity. So it's saying sum up all the areas here. So by the time you get to, let's say, at x equals b, that would then give you this here at x equals b. So the volume is really you summing up all the areas. But then the area for one specific area, it is given by this. So now this one specific area, when x equals b, is you summing up everything in the y direction. Okay, so that would be in the y direction here, and it was blah blah blah. We got to this stage here. Okay, we got to this stage here. Now, if you look at this here, you've got this multiplying with this, and we're moving in the y direction. So if you look at this here, so by the time it gets to b, when x equals b here, and then we've got to work out the area. Well, the area is moving in the y direction here, but then this b here is really a constant. It's not. When you were working out the volume here, you're actually moving in the x direction. Okay, but when you come to look at the area for this specific value of b here, b would then be a constant. So it's now you moving in the y direction. So b is a constant here. So when you're summing up the area here, when you're trying to work out the area, you're moving in the y direction. So b is a constant, x is a constant. So when you look at this here, hang on. At the end of the previous video, we got to this stage here. But when you get to this stage here, you've got this thing multiplying with this thing here. You're moving in the y direction. This thing here is a constant. B here is a constant. It has nothing to do with y because you're moving in the y direction. When you're looking at the area, you're actually moving in the y direction. So this thing here remains constant. So because it's a constant, hang on. Because it's a constant, we can actually remove this. We can actually take it out, so it becomes this. And remember, in the previous video, anything of this form here will be q. So remember, you're integrating from negative infinity to so anything of this form here, we're saying it equals q. That area that we were talking about. Well, this thing here equals q. So this will become this. Okay, so the area for the area is given by this. So hang on, the area is given by this. But remember, when we were trying to work out the volume, it's really us summing up all the areas. Remember our circle? We were summing up all the areas. So from negative infinity to infinity here, we're summing up all the areas. Well, the area is given by this, so we can put this into here. Okay, so that would then take us to this. But then the b here gets changed to x because, hang on. Hang on. So we got to the area here. So area for any given value of b is given by this. Okay, so we can then put this to here. That will then take us to here. But then the next step, the b changed to x because hang on, we are here at the moment. So hang on, let me try and explain why this changes to an x. Hang on. So we are, well, the volume is us really summing up everything here. Okay, so that's us summing up everything. So this bit here, the point that I'm trying to make here is that b here, this b here is for one specific value. We were trying to sum up everything. So we are moving in the x direction. So for any specific value of b here, then we have a term for the area. But then this b here is really, it's just us using it on a temporary basis. So when we come to sum up all the slices, it's really the x is moving along. So this b here is, you see, when we were working out the area here, the b is constant. Is because we're summing up all the y. We are moving in the y direction. But then when we come to sum up all the areas, we are moving in the x direction here. So this area here is no longer b. It is x. We are summing up all the. We are moving in the x direction. So for any given value, for any x value, we have a term for this area. Here, b is a constant because we are moving in the y direction. But when we come to sum up all the areas, you can see that x is moving about. B is over here. X is moving about. So hang on. So going back to here, I hope you understand. Going back to here, we've got the area here. The area is given by this here. So now to get the volume, we need to sum up all the areas. So we put it into here. So that would then give us that would then give us this. But then the b, well, because we're moving, because we're summing up everything, we're moving in the x direction. So x is moving all the time. So this b here, last time b was for one specific case, but because x is moving along, we don't actually need this step here. I'll put it in there to illustrate that. So from here, we've got to move to here, because this b here is for one specific case. But because we're moving along here, because x is moving along here, x is always changing. So and we're summing up in the x direction. So this b here becomes an x. Okay, so by right we shouldn't actually need this step here. We can just jump from here to here. Okay, so now that we're moving in the x direction, q here is a constant, so we can actually take it out here. Okay, q is a constant, so we can take it out here. And remember, when you see this term here, it is this term here. Anything of this form here, negative infinity, infinity, e minus t. Remember this dummy variable here. We're going to say this this thing here is, well, we're going to say it equals q here. So that thing there becomes q times q. So v equals this. I hope you understand. Okay.